Hello, geometry kids. I hope all is well with you guys. We get a new topic today, the ratios of the sides of a right triangle. Kids, adults, people see sine x, cosine x, and tangent x, and it scares them. It should not scare them. Sine x, cosine x, and tangent x is simply just a ratio. It's a fraction. A ratio is a fraction. 2 red cars to 3 red cars would be 2 to 3. That's a fraction. That's a ratio. That's all sine x. Sine x is simply a ratio of 2 sides of a right triangle. And that's what we're going to talk about today, are those 3 trig functions. They're called trigonometric functions. All right, so my pen came in, it did not work. So I have another one coming in Friday. Of course, not today. All right, so I'm still drawing with my finger. All right, so here we are. I just simply made a right triangle. And just for simplicity's sake, I'm going to make it a 6, 8, 10. That is a triple. So 6 squared plus 8 squared is equal to 10 squared. And we're going to go through what the sine, cosine, and tangent would be. So it is the ratio of 2 sides of a triangle. So we need to put an x here because I'm going to pick this angle. I could have picked the bottom angle. I just picked the top one. I don't know why I just did. That's just the one I picked. If I do the next video, I'm going to pick the bottom angle. It doesn't matter. All right, so I picked that angle, the top angle, to be the angle that I'm looking at. All right, so now what I need to do is I need to say, okay, well, what is the sine of x, and how do I find the sine of x? The sine of the x is the ratio of 2 sides of the triangle. So which one do I use, 6, 8, and 10? And which one do I put on the top, and which one do I put on the bottom? All right, so I can only use 2 of them. One has to go on the top, one has to go on the bottom. So the sine of x is always the opposite side divided by the hypotenuse. And I'm going to abbreviate because it's a really long word. And I can't write that well with my pencil, my finger. All right, so the sine of x is equal to the opposite divided by the hypotenuse. All right, now if we're talking about, I'll use my little pointer here, this angle x, then what side is opposite of that angle x? The opposite side is 8. So on the top, I'm going to put 8, because 8 is the opposite of angle x. If I had put angle x down here, then the opposite would have been 6, but I didn't. I picked the top. So the opposite is going to be 8, and the hypotenuse is always the same thing. The 10 will always be the hypotenuse. So there is my ratio, 8 over 10, which we reduce to 4 over, come on, draw, why isn't this drawing? Oh my goodness. That's weird. Okay, let me just click a couple things and see if I can get it working again. All right, 4 over 5. My goodness. Divided by 5. All right, well, let's just move on and see if it's going to work here. Okay. So next, we're going to talk about the cosine. So the cosine of an angle, okay, I don't know why this isn't working. Okay, the cosine, there we go, of an angle, so this is divided by, still not working. Okay, the cosine of an angle is adjacent, so A, B, J divided by the hypotenuse, HYP. Let me try something here and try and rewrite that because it's not very good. So HYP, there we go. And this is divided by, it's still not writing, divided by 5. All right, so the cosine of the angle is the adjacent. So if you look at the x, angle x, I'm going to go over here and show you angle x. Here's angle x. So when I look at angle x, I have 6 is adjacent and 10 is adjacent. But we don't call 10 adjacent because 10 is the hypotenuse. So 6 is going to be the adjacent. So therefore, the cosine of angle x is going to be 6 divided by 10, which then reduces to 3 divided by 5. Oh, so I don't know why that one is not divided by 5. I'm just going to put it in there. So 4 divided by 5. There we go. I have no idea why that won't write on there. Okay, there we go. There's my ratio, 4 divided by 5. Okay, my bad luck. Okay, the last one is the tangent. So next we're going to do the tangent of the angle. So the tangent of the angle, okay, tangent of the angle x is, so x stands for the angle, is going to be opposite divided by adjacent. All right, so what is opposite? Opposite of angle x, we already talked about that, is 8. And the adjacent of angle x, we already talked about that, was 6. And that would reduce down to 4/3. Okay, so that would be your 3 answers for this problem. So some people memorize this by what's called SOHCAHTOA. S-O-H, that stands for sine opposite of hypotenuse. C-A-H, that's my ka, sa, ka. Cosine is adjacent over hypotenuse, and then TOA, T-O-A. So that is how some people remember it. It's called SOHCAHTOA. S, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So you are going to have to memorize that. You will see that a lot on different standardized tests. All right, moving on to the next question. It says the right angle has side lengths 8, 15, and 17. That's also Pythagorean triple for a right angle. It says use these lengths to find the cosine of A, the tangent of A, and the sine of A. All right, so first I'm going to mark A. There's angle A. So everything is referring to that angle. All right, so it says cosine first. We're going to start with the cosine of angle A. All right, so there's angle A, cosine. What is cosine? SOHCAHTOA. If you want to write that up here, you can, or just have it handy so you can reference it. That would probably be a good idea. So the cosine is the adjacent divided by the hypotenuse. So hypotenuse is always 17 because that's the longest side is across from the right angle. The opposite is the opposite side. There's your 8, and the adjacent is your 15. So for the cosine of A, my adjacent is 15. Oops. And my hypotenuse is 17. All right, next I'm going to go to the tangent of angle A. So if it were angle B, it'd be different, but it's angle A. All right, so for the tangent of angle A, I'm going to do opposite divided by adjacent. So my opposite is 8, and my adjacent is 15. All right, and the last one for this one is the sine of angle A. So the sine of angle A is opposite over hypotenuse. So that would be 8 divided by 17. And if you notice, those are ratios of the sides. Sine, cosine, and tangent is simply just a ratio of 2 sides of a triangle. All right, moving on to the next example. All right, this is just like a generic triangle. It's just like the last problem we did, but there isn't any numbers in it. So that's not going to actually be terrible. So they already marked angle X for us. So we're going to do the sine of X first. All right, so what is the sine of X? The sine of X is opposite. Which one is opposite? Well, E is your hypotenuse. You can see that. Hopefully that's across in the right angle. So the opposite is F divided by your hypotenuse. That's going to be E. So that is the sine of X. You can put a box around these if you want. Next, we have the tangent of X. That's SOHCAHTOA. That's the TOA. So the tangent, and remember, we're always dealing with angle X. This is the angle we're dealing with. So we're going to do opposite, which is F divided by adjacent. Now, D and E are both adjacent, but E trumps with hypotenuse. So E is hypotenuse, and D is going to be your adjacent. So this is going to be D divided by, oh, I'm sorry, not D divided by E. What is it going to be, kids? It's going to be, it's not even going to be D there. I don't know what I'm thinking. Okay, so tangent of angle X is going to be opposite, which is F, divided by adjacent, which is D. And there is your tangent. All right, and then the last one we have is cosine. So the cosine of angle X is going to be adjacent, which is D, divided by the hypotenuse, which is E. So again, it's just the answer to a sine, cosine, and tangent is a ratio between two different sides of a right triangle. So sine, I'm going to check these, opposite over hypotenuse, F over E, tangent, which I screwed up on earlier, opposite over adjacent, F over D, and cosine is adjacent over hypotenuse. So those are correct. All right, 2 slides left. Okay, so for this one, I'm going to bring up a calculator. There's my calculator. So the ratio can also be written as a decimal, like 2 cars to 3 cars is 2/3, that's 0.6 repeating. And then as you can see, they tell you to round it to the nearest hundredth. All right, so I'm going to bring my calculator back up. And actually, I'm going to bring it back down and then make this a little bit smaller. There you go, bring up my calculator. All right, okay, so the cosine of 14 degrees. The first thing you have to do is make sure your calculator is in degrees. So go to mode and, oops, okay. And if you don't have a calculator, you can find one on your computer. So in the mode, you want to make sure it's in degrees. This calculator happens to be in radians. So I'm going to scroll down and move my calculator to degrees, and then I'm going to hit enter. So it's either radians or degrees. So if it says DEG in your calculator, you're good. All right, so I'm going to clear this out. Then now I need the cosine of 14 degrees. So to do that, I just type in cosine 1/4, close my parentheses, hit enter, and round it to the nearest hundredth. So that is going to be 0, if I can write, 0.97. Okay, now I just put in the tangent. So I'm going to put in tangent of 65, close my parenthesis, hit enter. The tangent of 65 is 2.14, and the last one is the sine. So I'm going to hit sine of 49. Close my parenthesis, hit enter, and that is, I'll use a different color, 0.75. All right, so you simply just find those on your calculator. All right, last one. We have about 2.5 minutes left. Okay, this one looks really long and complicated. It's actually not too bad. Okay, so for this one, it talks about it gives you 3 similar triangles. How do you know they're similar? Because 2 of their 3 angles are the same, so they're similar triangles. All these top angles are 58.8, 58.8, 58.8. So if you think of all the triangles would be similar, they probably would have the same ratio of sides, so we'll see. So for the first one, they want you to find DE divided by, or EF divided by DF. So here is EF, and here is DF. So for this one, it's going to be hard to write these in here. So it's going to be 10. Oh, it's going to be really hard. I might just say them and let you guys write them in. So it's going to be 10.32 on the top and 19.93 on the bottom. So 10.32 on the top, 19.93 on the bottom. All right, IJ divided by HJ. IJ is right here, that's 41.28. And this one here is 79.72. For this one right here, we're going to have QR, which is right here, 82.56, divided by PR, which is 159.44. Now, if you notice, for all 3 of these triangles, you're doing the adjacent divided by the hypotenuse. This is the IJ, this is the adjacent divided by the hypotenuse. This is the adjacent divided by the hypotenuse. So down here, when it says which trigonometric function is given for each of these sides, in this case, because it's adjacent divided by hypotenuse for all of these, it is going to be this one right here, which is cosine, which I'm covering up. Okay, so then once you finish this, you're going to change this to the nearest hundredth, and you should see that all of those should be the exact same because they're all ratios of a similar triangle. And then here you just put those into your calculator. So you get out your calculator and you're going to put those in, and then that's it. That's how you do that problem. All right, have a great day, and I'll talk to you guys later.